Intelligent Tutoring Systems by Olivia Zucchi. Science Direct 2014 defines intelligent tutoring systems as a computer-based educational system that provides immediate and personal feedback. Today we will focus on conversational ITS, meaning intelligent tutors that converse with a human learner. According to Russ et al. 2013, they typically outperform novice human tutors. Some of its success lies in its versatility. For example, these computers can mimic virtually any activity or social situation, including curious questioning, negotiation and argumentation, empathetic support, and thinking out loud. Most intelligent tutoring systems use EMT, or expectation and misconception tailored systems and dialogue. That means there are a variety of correct or good answers and a bank of misconceptions. Typically, these systems are designed with two loops. The outer loop decides the next task, while the inner loop manages the student interactions, like checking for understanding and providing scaffolds. Sometimes this one-size-fits-all approach is used, which means all students get the same set of questions. However, it is more effective when the intelligent tutor can adapt to the student. In recent years, there have been advancements in ITS, including number 1, macroadaptivity, or the ability to create more personalized learning progressions. Number 2, deeper dialogue. Computers are now setting conversational goals to better coach students and correct misconceptions. And number 3, designing for affect. Tutors can respond or anticipate how a user will feel. All of these advancements make the learning experience more like working with a human tutor. According to McLaurin et al. 2011, it doesn't take much for humans to see computers as learning partners. So whether a machine looks like this, or this, when social cues, polite wording, and cooperative attitude are used, people will accept a computer as a learning partner. McLaurin et al. 2011 tested how politeness affects students' motivation and learning. Positive face is the desire to be liked, appreciated, and approved. Hearing statements like, "I like how you did that," promote positive face. Negative face is the desire not to be imposed or intruded upon. Basically, humans need to exercise autonomy. Power, stance, and rank may threaten face. For example, your boss saying, "Do this immediately." When politeness was tested in a lab, results showed that politeness motivated students, promoted better learning, and had a stronger effect on students with less prior knowledge. However, when tested in the classroom setting, the results were not replicated. Low prior knowledge students did not benefit more from using the polite version of a tutor. However, in both scenarios, it was beneficial for students who made the most mistakes. With conversational ITS, a person can talk to one computer, which is called a dialogue, or a person can talk to an ensemble of agents or several computers. Grayster et al. 2017 tested how a trialogue, or a discussion between two computers and one human, can affect learning. In this dynamic, the learner is interacting with a teacher and one peer. In this dynamic, the learner demonstrates mastery to transfer knowledge to two other students. Najjar et al. 2016 studied intelligent tutoring systems and worked examples. Worked examples are mostly used for problem solving, and they illustrate each step of the problem. A faded example is similar, but only shows parts of the problem, like this example here. Najjar et al. 2016 designed the ITS to adapt to the learner's needs using faded examples, and depending on how much assistance they needed from the previous problem, would provide more of the faded example until the student was able to work on their own. The results showed that students in the group with the faded examples learned more procedural knowledge and at a faster rate. The reason this works boils down to cognitive load theory. Our brain categorizes information into buckets. The intrinsic load is the nature of the concept and how difficult it is. The extraneous load is all the stuff that is part of the problem but not necessarily needed to solve the problem. Lastly, the germane load is needed to process and construct schema, which helps us place information in our long-term memory. When there is too much information and we have to sort out what is important and what is not over and over, we experience cognitive overload. The adaptive scaffolding of the faded example reduces cognitive load and frees up our working memory because there is less redundant information. Some intelligent tutoring systems can read user affect or emotions. For example, some of the main emotions it can detect are when the user is happy, bored, annoyed, and most importantly, confused. According to Lindenbring and Pintrick 2002, confusion raises affective filter which negatively affects or blocks learning. Therefore, the teacher, in this case an ITS, must be able to assess affect on the spot to tailor the lesson for the student. According to Saltlayer and Proctor 2012, there are many ways to detect affect, including measuring face changes, mouse movement, thermal imaging, and reaction to goals. Additionally, it is important to differentiate between mood, emotion, and personality. Roscoe et al. 2013 implemented WritingPal, an ITS that offers writing strategies and instruction through game-based practice and essay support. In general, these high school students found it beneficial for their writing, and at worst, it was boring or a little bit too long. Roscoe et al. Also pointed out that students' perception of an ITS affects how effective it can be. In conclusion, ITS is growing and adapting, though more systematic research is needed. Currently, it is costly in terms of time and money, so large distribution may not be feasible. In the future, it may be possible to use ITS in more classrooms for general education lessons or for assessments like English learner placement examinations. Thank you so much for listening. Here's a We're Excited page of all the references I used.